Hello everyone, welcome to Yourpedia and this is Shubha. So today I'm in IIT Kanpur and I'm in Mechanical Engineering department. Right now I just got a chance to meet one of the amazing professors. I would say that he's one of the person who has given multiple social innovative grassroots level kind of things, and I would be calling his name, and that is Professor Bisakh Bhattacharya. He has a lovely name and I would request sir to please introduce yourself with a brief meaning of your name too.
Oh, okay. So two tasks then. Well, then first come to the name. As I was discussing that this name has two meanings. One is that somebody who doesn't have a branch. So my father really was very ambitious that I would be a unique person. And secondly, it has a mythological connection. That is when Lord Kartik was attacked by a Vajra, he simply just made a scratch on his arm, and from that got created a golden replica of Kartik. And so somebody whose birth has taken place through the scratching of Shakh means branch, so that also you can call Bisakh. And since my father's name was in the name of Lord Shiva, so it also justified my name to be as in the name of Lord Kartik. That's the way the tradition was.
So sir, you were a bright student from the very scratch?
I don't think I was too bright, but I was laborious, hardworking, and I had a deep inclination towards literature.
Oh, that's
in fact, that was my sort of first love was literature, and so my imagination was very strong. That's true. However, as you see in a middle class family, the stress was in terms of getting a job.
Right.
So after the 12th education, I had to sit for competitive exam. And even though I was preparing myself to take my undergrad study in literature, but as my luck or bad luck goes, I got admitted both, not admitted, I got selected both in medical as well as engineering.
Oh.
And then, I sort of chosen engineering because I was afraid of remembering too many things in biology. So that's why I thought that this may be less taxing from the memory. So I choose engineering.
So I think rote motivation is that of technocrats. They are quite technical, right?
Yeah, they are. Yeah.
Okay. And your father truly identified your name because it is like Honhar Vidwan ke ho chikne paat, and you are the true replica of that, I would say.
I don't know, but there is something really that all parents, they create a vision for their kids. Right. When they name them. I kind of, when I look back, I see that is something that has happened in my life, because I tell you a story that why that thing has happened. See, when I did my engineering, my undergraduation, I did it in civil engineering. So I was BE in civil engineering from a reputed university in West Bengal called Jadavpur University. And then I did my master's in mechanical engineering. Okay, so I changed the branch from civil to mechanical in my master's, and then I did my PhD in aerospace engineering. So you see that I traveled all the paths which are associated. These departments are all linked, of course. That way I think that career path was very kind of a risky path. Somehow I survived.
So sir, I just got to know that you are into innovations till now and you're just contributing towards that. So can I just know about your academic and research contributions or the background journey of yours?
Oh yeah, sure. Yeah, as I was telling you that the single common thing that sort of attracted me towards all these different branches is that I had a fascination for Star Trek. So that means something which is futuristic in terms of engineering.
Right.
Okay, and particularly what attracted me is the dynamics and the control of a dynamical system. Okay. So anything that is dynamic, anything that is moving, that has its own beauty, and it is as fundamental as modern, because it is fundamental because it was discovered maybe from Newton's time, And it is modern because even today we are continuously discovering new systems of transportation. Like today we are talking about hyperloop, we are talking about space crafts, so all modern transportation systems, their dynamics are different. So dynamics is always there. And then in my journey I also added another fundamental subject with it, that is called control. So control is something through which you can actually sort of modify the trajectory of a dynamical system. Let's say you are moving a car, so if you have the control about it, then the car can actually change its gear automatically. You don't have to do it. So these are some of the things that are integrated. So here I focus on these two subjects together, dynamics and control, and its various manifestations. There are two manifestations there. One is my pet subject, it is called smart material. There are certain materials which are very unique in their nature. They respond like a biological system. So if you use such a material, you can develop a nice controllable system. So that is one focus. And the other focus is robotics. Robotics applies all these ideas together in order to create something.
So the best spoken words by you. I would like to add something, that what about the best of the research facilities which have been created in your research arena? Well, you talked about this automation, the gear facility, you talked about the robotics. Apart from things, this, anything you would like to add?
Yeah. So I would like to tell you that when I joined in this institute 25 years before, in this department we didn't have this subject called smart structures. That means where really the materials can talk to the system and you can develop actuators and sensors. So the challenge from Aeronautical Research and Development Board was to create something for vibration control of different types of aircraft systems. So we developed a unique facility for vibration control using smart structure. Secondly, I was given another challenge by General Motors that for their automobile, advanced automobiles, they want a shape control. And later on, a similar challenge also came from ISRO in this direction, that for their antenna in space, they want a shape control. So this shape control also, I could do it with the help of these smart materials. So we have developed a full-fledged shape control facility. And then there are innumerable really number of facilities that you have added. Fundamentally, they were either more modifications, more profound version of vibration control. Like today we have a meta structure or meta materials, which is something like Harry Potter's invisible cloak. Just like a cloak, if you put, you are invisible. Similarly, in the area of sound, if you actually put this kind of a structure, then that structure cannot be detected by any radar. So it has a huge application. So we have been able to, this is one of the first laboratory developing the meta materials, meta structure facilities. I would also say that there are some other endeavors in which we are first in the country. One of them is that in the field of robotics, with an application in gas pipe field, we are the first to develop a complete pipe network. And then we have developed a robot which can go inside these pipes and can track what is the kind of situation in the pipe, the health of the pipe. And the ramifications of that is in terms of what you call the development of hyperloop, cargo hyperloop. So we are developing with Coal India, in terms of developing hyperloops for coal carrying.
So I've seen that students, whenever they visit any institute, they are very much fascinated with the infrastructure that is available. I would like to ask you, particularly with respect to the infrastructure that is available in research laboratories, what is in comparison to the global institutes? Like if I have to compare both the institutes, the global level institutes and the research facilities available in your laboratories, how would you compare both?
Well, it's a very relevant question. In fact, if you consider the laboratory infrastructure, we are luckiest in that sense that government has given us enough funding, along with all the other industry they are regularly pitching in. So our laboratories are certainly the best. And you see, we had the best of the genes because 7 institutes of US co-created the Department of Mechanical Engineering, and one of them is MIT. So
Okay.
just by the side of my office, I will show you that one of the very important contributions they had done, and that machine is still running today, is
Okay.
how to measure the transmission of vibration from one point to the other.
Right.
So our infrastructure wise, of course, we can do better, but right now we are incomparable. We have a 3-dimensional laser Doppler vibrometer through which I can hear even the heartbeat of a grasshopper.
Okay.
Okay, so it is so fine. It's like in the nanometer level I can sense. Similarly, we have SEM facilities through which we can see the microstructures. So hardly there are such mechanical engineering laboratories in the country.
So I would say that the hard work of IIT Kanpur would be showcasing with the research facilities that are available.
Some of it I would be able to show you. Some of the other things my other
Best
colleagues
is we
are
can
doing.
give a glimpse of to the
Sure,
students.
yeah,
right?
I'll be happy to do that.
Okay, sir. So, sir, I would like to know that can you suggest some of the research areas where students, whosoever want to make a prospective research, they want to follow your footsteps. So, where they can just build up their careers in the research areas which you can help them figure out.
Yeah, I mean, there are two aspects of it. One aspect is from the undergraduate studies point of view,
Right.
and maybe that we can touch subsequently.
Okay.
But if we first touch the research areas, let's say those students who have taken undergraduate education from other institutes, maybe Tier 2 institutes or some other IITs, and they are looking for good research facilities.
Right.
Then a mechanical engineering department is very famous in certain areas.
Right.
So we are broadly into 4 streams. Stream 1 is called solid mechanics and design.
Okay.
Stream 2 is robotics. Stream 3 is fluid mechanics and energy conversion. So fluid and energy you can call it. And stream 4 is in terms of manufacturing.
Okay.
So we are very strong in all the 4 areas, and in all the 4 areas all the cutting edge facilities are there. If you want me to say about some key areas of research, of course there will be my personal bias, but I can tell you that for example, if I start from solid mechanics and design, then the current research in metamaterials and smart materials, they are very, very fascinating. Sensors and actuators, they are quite good work is happening. Robotics is of course always there, but particularly in the stream of robotics, soft robots are coming up in a big way. So industrial robots, it is developed so much that not much of research is left there. But soft robots, animal and humanoid robots mimicking these, social robots, cognitive robots, these are some of the upcoming areas.
Okay.
And now if I come to manufacturing, one of the things that is coming up in a big way is called additive manufacturing.
Right.
So for a long time mechanical engineering was involved in what we call subtractive manufacturing. That means you take a chunk of material and then you actually get something out of it, pretty much like what a sculpture does. So discarding materials and creating a form. Now today, because of the sustainability drive, we cannot afford so much of material loss anymore. So today we develop a system bit by bit. So it is additive. So it is a bottom-up procedure, and that's the thing that manufacturing is developing in a big way. Fluid mechanics and the energy part, of course, energy is one of the most important thing today.
Right.
And fluid mechanics is lot of having interfaces with solid mechanics in terms of fluid structure interaction. Let's say if I develop a bullet car, then a bullet train, then I need to know both about the aerodynamics as well as about the train structure or shape. So that's where the two fields are.
So students would like to know the career opportunities which are available after they focus or after they do the research in your domain.
Yeah. In that I will remain specific to my domain. So what I see mostly our postgraduates from my laboratory, they are 100% employed. I never see them, and their range of salary is from 20 lakhs to 50, 60 lakhs or so. So that's their starting salary. So what I see is that automobile companies, they are the big takers, number one. And then the energy companies like General Electrics, for example, they are the big takers. Manufacturing industry, like high precision manufacturing industry, they take our students very much. And of course, some of them goes for higher education, PhDs and postdoctorals.
Okay. So, sir, if any student who wants to do mentorship under you, so what are the key skills, I would say the prospective research skills which you would like to see in a student, and you will be choosing them?
So there are two parts in it. One is the skill and another is the attitude.
Right.
So until and unless I see both, I do not generally admit. Okay. A student may have all the good skills, but a student may have an attitude. So that, you see, one important thing I want to tell you is that intelligence is kind of same everywhere.
Right.
Okay. It's the passion combined with hard work that makes the change in a person. Okay. And we believe here in teamwork, because no complex system can be developed alone. So all these students, there are near about 40 students, undergraduates, postgraduates in my team itself. So they all co-create a system together. Right. So you need a proper attitude so that you can have a teamwork. That's very important. In terms of skills, of course, what I look for is that they have a strong mathematical foundation. Right. Because mathematics is the common knowledge for all of us. Right. And secondly, some knowledge is related to some of the softwares of our domain. Right. That is required. Some softwares related to dynamics or controls or robotics. But of course, most of the times the students pick up all these soft skills in the laboratory itself. I really look for another thing, that is a steady, good record of education. It should not be like, the 10th and 12th and college, all the records are showing lot of oscillations there. Right. So that is something that also we look for.
Okay. I must say that after listening to all your words, the students would be very keen to join your mentorship, right?
They do join every year, every summer the lab gets full.
Exactly. So how can a student prepare to avail that opportunity to be under your mentorship?
As I told you that the first and foremost point is that they must do good studies. Their education record should be good. Right. Their CPI should be good. I never go for that the topper kind of mentality, but there should be a level at least. Something like 7.5, 8 CPI. I tell them, okay, you have reached a level, so you can come. Okay. Otherwise, they will not be able to absorb. Second thing is that try to do something hands-on. This is an important point. You see, we are in engineering, and in engineering, just like in medicine, a doctor has no meaning until and unless he cures a patient. Right. An engineer has no meaning until and unless we do something for our society. Right. So that inclination should be there. Some people has only the habit of working in computers. We do not really want those group of students. We want students who have really done, even if a simple elementary, let us say, kind of a fan or a small robot or something, which displays some functionality. We are very happy that the student has that in it. Okay.
So these days, many Indians, I would say that India is promoting entrepreneurship though. Yes. Right. So related to your skill, your domain, I would say particularly, how a student can build a career in entrepreneurship, or I would say that he could avail such opportunities.
I'm so happy that you raised this point. You see, there are various academic models that we try to follow. Right. One of the important model, you may say, is called the MIT model. Oh yeah. And in MIT, every laboratory led by every professor would be having hundreds of entrepreneurs surrounding them. In our country, we did not realize it for quite some time. So our ecology was different. We were getting funding from the top and we were doing our research. Right. But really the ecology should be the other way around. We are generating skilled manpower. They should become skilled, great entrepreneurs. Then they should fund back our research. Right. So keeping that point in mind, our current drive is to create as many entrepreneurs as possible. Right. I'm happy to say that one entrepreneur group has come up from our laboratory in the field of robotics, and there are getting inspired by them, there are many others who are actually queuing up. So yes, it is very important.
So post-COVID, we have seen that students have entered or they started building their careers in CS much more than I would say the other streams, because they get the comfortable job opportunities too, and the advent of IT is much more, right, I would say these days.
Yes.
So do you still think that the trend is going to change after 5-10 years, or it's going to remain same?
Yes, if you look at it, I do not have to say, even if you look at it, that how these giant software companies,
Right.
how they are actually curtailing the jobs.
Exactly.
Okay, then you will get the message. And particularly if you look at it, that that era of so-called call it that sending people for software jobs abroad for a great
Right,
salary.
right.
Those things are coming down very fast with the aggressive posture of US, for example.
Right.
Okay, so now I think today's students, I tell them that let's not go for softwares anymore. Okay, software's boom is kind of, it is saturated.
Right.
Okay, something that will not saturate so easily. If you look at it, what are the powerful things of our country? One of them is that we have a big sense of culture and big sense of aesthetics.
Right.
So the field which is closest to this is called design. So our people should go for more product design. Why can't we design our own Formula One cars like the way the Italy does? I compare the only two countries in the world, India and Italy, have this culture and they have the capability of designing something which is fascinating. So that is one field in which more people should focus on. The other thing, of course, is that why can't we develop our own motors? Why do we have to buy them from China?
Right.
So engineering, particularly the hardware part of the engineering, the student must focus on.
Right.
And the third important thing that is coming because of the energy, driving energy.
Right.
So I think the silicon technology is something that they must get the opportunity to study anything related to the silicon technology. That means semiconductor technology, micro machining, micro manufacturing. These are the things that they should look for. The course or curriculum that offers such a thing, the student should jump on it.
True, sir. Saturation comes about after everything. I would say that there is a certain level, and then saturation is there. One more thing, like as we are constantly, you can say, using the softwares like AI is there, or I would say that ChatGPT, everything, it's there in the students right now that they do use it out. What do you think that students should focus on the level of the creativity? With the advent of AI, is it impacting the creativity level or it is not?
It is impacting both ways. I mean, if you want to take it in a positive way, then these AI along with certain tools like this additive engineering or 3D printing that I was telling you is actually empowering us a lot.
Right.
So if a student has a new idea today, then he or she can actually develop the idea in the form of a conceptual product at a much faster rate than maybe 50 years before.
Right.
So that is the positive side of it. The negative side is that getting complacent about it. That you can answer questions through ChatGPT is getting complacent about it. You see, unless our brain is challenged, we will never do something which is more creative, something which will be more important for the society.
Right.
So the student should be aware of it, that this has a razor's edge, you can call it.
And one more thing, I guess Kanpur is in making, right? So what is the contribution of IIT Kanpur right now in that?
Yeah, I think it's a historical moment for Kanpur now.
Yeah.
That's because, as you know, Kanpur was called the Sheffield of UP, for example, if not in India.
Right.
Kanpur was great in manufacturing industry once upon a time, but then it declined.
Yes.
We could not reinvent ourselves. One of the reasons, there may be many other reasons, one of the reasons is that we lost track of the skilled manpower. Skilled manpower is absolutely important. That means people who know about the modern technology.
Right.
So how do they know about it if we cannot create an infrastructure to actually train them in a, we call it real life environment, the way they are going to face it in industry? That is something that our Prime Minister has a dream project in Kanpur. So the Indian Institute of Skills there are 3 of such institutes that are coming up as model institutes for the country: IIS Mumbai, IIS Ahmedabad, and IIS Kanpur. And interestingly, IIS Mumbai and Ahmedabad is getting developed by the Tata groups, but IIS Kanpur is mentored completely by IIT Kanpur.
Okay.
And our role here is that to develop curriculums not just for students who are graduates, B.techs, or say masters or PhDs. We are going to cover the entire spectrum. We'll start with people who are maybe 8th or 10th standard. They still may be having a small engineering gene in them because they might be doing some ITI training somewhere. How to give them more advanced training, which will be good for our defense as well as good for our applications of modern technology. Let's say in leather technology, let's say in textiles, let's say in agriculture. UP is good in all these 3 domains. So this is what will be the aim of IIS.
Okay. So, sir, it was great talking to you, and I value your time. You gave us your time. That was much more important for us. But at last, any of the message you would like to share with the students to motivate them, to encourage them, whosoever is watching this video of yours?
Yeah, I just would like to say that you should not get bothered about the peers. The journey of your life is actually your own journey. The story is your own story. You have to create the story by looking at yourself, that what is it that you are good at, not what everybody else is doing. Often it is the mentality of flocking like a sheep that creates a problem. We need those type of citizens for our country who can actually think on their own and create on their own. That's all.
Such a beautiful message, and thank you so much, sir, for your time.
Thank you.